Welcome back. We're going to go on to the processing of inputs. Obviously, we all know what an input window is. An input window is a window with fields on that we can ideally do input in. Those fields have the editable and uneditable fields, because a lot of the time you'll have a record area and you'll define your input window with your dot fields on, and then you'll create a local structure and have other dot fields on. So for example, if you've got a product group, you'll have a product description at the side of it. We don't actually implement that in this example, but it's very simple to extend data objects and all that kind of good stuff using this whole concept. We're going to keep it simple. The input windows generally are defined in the script file, ideally from the repository, because if you've done it from the repository, that means we have a repository to build data objects from, which makes things a lot easier. I did talk about styles this morning, and I'm going to go into more detail with styles this afternoon. The similar sort of concept of menu processing, we have an input loop, we display, we load, create, define an input window, place it on the screen and go into a process loop, and we basically respond to two events, either a menu or a set. We've also got break processing as well. I'm sure some people in the room do break processing. It's not a problem. We can handle it, and we do handle it, but we don't demonstrate it in this afternoon's. We demonstrate change processing, but that's a little bit later on. So you've got an input window, you define the fields, you give the fields the positions, you tell it where you want the prompts, etc., etc. Ideally, as we say, everything comes out of the repository. So all the information about a field, its prompt, its change methods, its drill methods, its validation type, does it have to be in a certain range? If it's a date field, do we default to today? All that kind of stuff. We also define input sets. Input sets obviously are used for defining the fields within the window that you want to input into. By default, there's a sort of all set with all the fields in. But a lot of people generally will use input sets to limit the fields. So in our example, if you're in amend mode, you'd have an input set that didn't have the part. Because if you're in amend mode, you don't want to be changing the primary key, which is the ID field. If I want to create a new record, then all the fields in a set would be enabled. So you can use set processing input processing in the toolkit to control what fields do and do get enabled. So your code, you don't have to say, right, at this point in time I want to be able to get to this field, and this field. You define the sets in the input window, name them, and then you process a set. So you'll say, I want to display into a set A, I want to input into set B, and I want to display into set C, and input process into set D, etc. And we try and mimic that and follow that concept and that approach into the Symphony side. As I highlighted on the previous screen, the more information you get from the repository, the better. If you've got information in your script, we can, using CodeGen, bring a script and a repository together, but ideally it's better to get everything in the repository. Your method processing, the two methods we honor currently are drill methods and change methods. We do register against the data object an arrive and leave method, but we currently don't do anything with them. It's not that we can't, but the performance of input processing in WPF, if you've got arrive and leave methods that are firing every time you go anywhere near a field or leave a field, pretty much starts to kill the system. It's not good, depending on what you want to do in those. And I've tended to find when I've done this that any logic in an arrive and a leave method can generally be done elsewhere, i.e. pre-processing of the form or in a change method. Generally, I'm not saying that specifically everywhere, but generally. And as I say, as far as I'm concerned, the preferred way is from the repository. Get it defined in the repository, it makes code generation a breeze. So here's a quick example. You load the input window, the name of the input window is obviously important. And what we do in our example is we put it into a tab set. So the first tab of our application has got our listing, so you double click on one, and that brings basically up the second page of the tab. And once you're in page one, you have to click an item to go to page two. It's not the best interface. It's what people do. I'm showing in that simple example what people do. So if you've got a tab container, you should really be able to move around the different tabs. It's not great processing, but it's the way Toolkit tends to work. So you've got your standard repeat loop, do something, wait for the input processor to respond to whatever the user does, and then they'll have either hit a menu entry, and the menu entry could be a button on the input form, it could be a button on the toolbar, it could be something you've signaled from a change method, it could be something off a menu bar. Doesn't really, you don't care, but it can come from all those places. And obviously you've got the change method processing. It doesn't come back to the code. The toolkit handles all that for you and calls the change method. Break processing would come back down into here. So if you want to handle break processing, as I said, we don't in this example, but it is doable in this framework. So again, I'm going to mention a Symphony data object. This Symphony data object, as I said, it represents your data. You're used to representing it as a record area. But if you think of your record area as now a data object, and when you say record area equals, that's like saying synergy record equals, and the individual fields become the properties, because they have to be properties, because we have to have logic behind the property. You can expose fields from a class, but there's no logic associated with it. So if somebody puts data into it, you don't know that data's been put in. With a property, you get methods, a get and a set method. The get method gets called when somebody wants to get at the data, and the set method gets called when somebody wants to deposit data into it, value into it. Which means because it's a method, you can do additional processing, additional logic, which is, for example, in the set method, that's where we would raise property notifications to tell the user interface that the data's changed. As I mentioned earlier, we've got this concept of it being valid. It doesn't validate that the data itself is right. It's to say, if it's a required field, has it got a value in it? Okay? And you can extend that by being able to set the validity of a field. And by setting the validity of a field, that will set the validity of the whole data object, based on all the other fields, not just that one field. So you can see the code there, where you're saying field valid details. That's saying, this field named supplier ID is valid. I don't care what value's in it, because I've worked out that it's valid. If, for example, in a change method, you want to set the details invalid, you'd set field error details, the field name, and then the text. So that's what you would appear if you did your message box. You've entered a bad supplier, or supplier is not valid, or supplier is required. Message box to the screen and stop the user in the tracks and halt them there. We tend not to do that. The moment you call that second line of code for any field within your data object, that then says, right, this whole data object is now invalid. Doesn't matter whether it's one field or all the fields. As soon as at least one field is not valid, the data object becomes invalid. When a data object becomes invalid, you can bind to properties that allow you to control when buttons are enabled and not. So if a data object is invalid, you would disable the Can I Save It button, for example. There's also ways inside the data object, from a user point of view, you can present the information contained within a data object, for example in a list, that says your data object's invalid because of these reasons. So there's a collection of error information that would hold things like that supplier details not found. Okay? So if you've got a data object with half a dozen fields in it and 3 of them are invalid, you would be able to get an array of error informations that say these are the 3 fields and these are why they're invalid at any point in time. That's why it's a clever thing, this data object. It doesn't say, yeah, I'm not valid. It can actually tell you why it's not valid. And you can present that through your interface, user interface, if you so required. We have methods within the data objects. Init data says initialize the data. So if you say part item, which is our data object, .init data, that initializes all the fields within your record area and thus all the properties that the data object exposes. When it does that, it also sets any default values. So if you said this is a date field and default to today's date, then it will put today's date into that field. If you said this field starts with a value of 1, it will put 1 into that field. So it sets the initial values as well as initiates and clears the other value. And then we've got this synergy record. Synergy record is the way that you can communicate between the traditional program and the .NET data object. You could set each individual property, but if you've got a dozen fields, 2 dozen fields, 100 fields on a record area, and thus in a data object, it will become a bit cumbersome to say, the property of my data object equals this value. The next property equals this value. So we've exposed this one single property called synergy record that allows you to say, the record I've just read from a file, synergy record equals it. Boom. One line of code and you've got the data from your file into the data object, and thus throughout your user interface. If you want to get at the data inside your data object, again, you don't have to get the individual fields. You can get the whole record area using synergy record. So the top one is getting your data out of the data object, and the second one is putting the data back into the data object. And then we've got field states. And this is essentially where we can do set processing. It's not identical, but it's the sort of best way, in my opinion, that we can do this. So, we don't define a set within the data object. The data object just contains the fields. So you have a bit of extra logic that says, well, if it's set all, then do all the fields. If it's this set, then just do these fields. And you'd code that within your view model, okay? Because it's not appropriate in the data object, because that data object can be used in this program, and this one, and this one. And all 3 different programs have different input forms, have different set processing rules and requirements. So that's in the view model, not the data object. But it allows you to, for example, set field enable status to true or false. Obviously, true means the field is enabled, therefore input into it would work. False means it's not, so it would grey out. And when we get onto styles, you'll see that if you use the code-generated styles and use labels for the prompts, then when you grey out a field, the label will grey out as well. Or when you disable a field, both the label and the field will grey out. So again, it's more ensuring the user is aware of what's going on and what's happening. It handles the same sort of syntax as Toolkit processing. So you've got star all star. That says all fields. So you don't have to list every single field in your data object. If you do want to do individual fields, you name them and you separate them by commas, just as you would do in set processing. Exactly the same as you do in set processing. And you've got enable state and read-only state. Yes, Alan. Alan's question is, it seems that it's either all or individual listed fields. And therefore, is there a way of grouping them? Inside the data object, no, there is no way of grouping them. That's what I was just saying. Each program would define in the view model a process by this name means these fields. So you define the sets and the names of the sets at the view model level, not at the data object level. Okay? So let's get on to styles. Styles are not required, first off. You don't have to use styles. If you do use styles, it helps you. And I'll show in the framework update on Wednesday afternoon, as well as standard styles using out-of-the-box WPF from Microsoft, I've also started putting together styles for DevExpress and styles for Infodristics. So the same code in your window, if you point it at a different style, your controls will look like standard WPF, or they'll look like Infodristics WPF controls, or they'll look like Telerik's or DevExpress's WPF controls. So it's a very nice and simple way of being able to tailor the way your input controls work. And it saves you coding an awful lot of XAML. Styles are based on what you've got in the repository and the code generated using CodeGen. So if you've got prompt information, required, etc. It also puts the data binding in there. One of the biggest pains of WPF is data binding because it's so case sensitive. If you get the case wrong, you don't get an error, you just don't get any data. Okay? Because the bindings doesn't work, because it's case sensitive. If you use code generated styles, it writes all the data binding in there for you, so you're not going to get the case wrong. It ensures that things change visually when various attributes or properties inside your data object change. For example, and we implement this in the exercises today, that the field background will go a nice shade of red if it's in error. So if there's an error associated with it, the style is code generated in such a way that the background of the field will go red, or a shade of red, and the tooltip will display whatever error information you've given it for that individual field. As well as the prompt information, we also define the header information. Remember a few slides ago, I said, when we were defining the grid, I showed you the XAML on the slide. It said header was a static reference to part description ID or something. Well, that static reference was actually something we've defined in a style. So if you define report headings in your repository, you can use those inside your grids to put the headings on top of your grid columns. Ideally reducing the amount of code and standardizing the way your applications look. So the header, this is what gets code generated inside a style file. So you've got a key called part ID heading, and basically what the value is, part space ID, that's what we've defined as the report heading inside the repository for the part ID field. The prompt information is exactly the same, but we are doing additional processing. We've got the same key, part ID, prompt. Because you've got the same names in various structures, the key's made up from the structure name, the field name, and what sort of style it is. So the first one, structure name is part, field is ID, the style is header. Second one, structure name is part, field is ID, and the style is prompt. And you'll see that there'll be a different one for the actual input style. But on the prompt, there's a couple of things in here. You've got this binding around here. And that's the way that this prompt knows that if the ID is enabled property on the data object that we've code generated, if that is set to false, then this label will be all grayed out. And that's the way it works. Okay? The label, if you put a label next to a field, it's not sort of mega clever in the XAML editor to say, I bet that prompt's for this field. It has no clue, because you can put them absolutely anywhere, on top, underneath, doesn't matter. Generally, you'll put them left to right, next to each other. So you need a way of saying, well, there's a common binding between these, which is ID is enabled. That means if I set it, this field wants to go disabled, and this label also wants to go disabled. So it's all coded in for you when you code generate the style. I'm not going to try and explain what's on that slide. If you want to go to that file, you can. The next few slides are this in sections, okay? I put it all on there so you can see that's the complete style for a single input field, okay? So you've got a unique name, part, structure name, ID, field name, and what it is, it's the style. Target type, Symphony controls field control, that's an anchor point. That makes sure that if I define a field control type of input control on my view, I can apply a style to it. It's just an anchor point. It's nothing more than that. These first bits, don't worry about them, other than to know that getting focus to a field, an input field, on a WPF window form is quite a painful task. It really is. It surprises me how difficult it is to say, would you have focus, please? It's atrocious how difficult it is. It's very easy if you name the fields on your input form and you use code behind. Two of the things that you must never do in a WPF application is name a field to then use it in code behind. Not good. There are exceptions, I do appreciate that. But generally, if you've had to name a field on an input form in XAML to then reference it in code behind, the chances are you're doing something wrong. Not saying categorically you are, the chances are you're doing something wrong. You need to go back and rethink and relook at it and say, do I need to do this? Now, naming controls entities within the XAML to then use within the XAML, that's more than appropriate. And I have to say that because it's on the next slide. So it's a text box. That's the type of entry, so it's just a regular text box. That could be a date picker, it could be a radio button, could be a combo box, doesn't matter. It's a simple text box for us. I'm naming it. I've just said don't name controls inside XAML. Yes, you can. What I said was don't name controls inside XAML that you are doing so to reference in code behind, because that's where you're probably making a mistake. But to be able to name it and then reference it inside the same XAML, that's fine, because you're not sort of going to code behind. And we'll see where it's used in a minute. The text property of a text box is what physically gets written to and seen on the screen. So here's our binding. So we're binding to the ID property of our data object. Update source trigger. It's a really nice thing in WPF. You can tell it, well, tell me the data's changed when one of two things happen. Either the lose focus, so they click somewhere away, or the physical property changes. And that's nice because as they're typing in, you can be going off, calling methods, finding data, filtering, and all that kind of good stuff just as they're typing in. So you can do some really, really nice things in the user interface. Validates on data errors and the validation stuff. That basically says if the data object or the entity that's being data bound to, in this instance ID, if that's invalid and the data object raises a hey, I'm not valid event, stroke status, then this says yes, honour that. And by doing so, that's where we can do the error processing, shading the thing red. Max length, width, character uppercasing, hopefully those are pretty straightforward, but they're coming straight out of the repository. So if you've hit the checkbox in repository that says uppercase only, then we'll enter the character casing attribute in there. Max length and width, because things are strings in .NET, if you don't specify a max length, they can just type and type and type. The fact that you've got an A20 and the next 30 characters will just drop off the line if they've typed in 50 characters, what do you want to do? You're not getting an error, it just disappears. So at least we can here say you can only enter 20 characters because our underlining data source can only handle those 20 characters. Other properties that the data object exposes is enabled is read-only. They're data bound too. So that is enabled is the same property that the label binds to. So you set that property to true and both the field and the label will honour the I'll go grey. Now they're only going grey because the control author has defined that an disabled state of a label and a text box out of the box with WPF Microsoft is to go greyed out. You could make it blue with pink spots if you wanted to. You can restyle those as however way you want. This is not telling the user interface what it should look like. This is telling it what state it's in, and then the UI designer of the styled text box and label has defined that it goes grey. But it could easily go pink, blue, flashy, red, whatever you wanted it to. All this is doing is the tooltip. The tooltip, this relative source to self, validation errors. I told you about this collection of errors that a data object will expose for all the fields that are in error. That's basically where you're accessing it. So it will get the correct error information for that field. So if its supplier is invalid, it will display supplier as invalid in the tooltip. That behaviors, all that does is, in standard WPF, Microsoft, they're a wonderful company. They do fantastic things, and the developments they provide are amazing. But I'm sure sometimes at 5 o'clock in the afternoon or 9 o'clock in the morning, they go, I'll take my brain out while I'm going to do this bit. WinForms, the way we've all been processing and running applications for donkey's years, when you tab to a field, there's any data in that field, it selects it all. Correct? So it'll go slightly blue, and if you start typing, you'll overwrite it. So everything that was there will disappear, and whatever you type appears. Yeah? WPF, nah, it doesn't do that. WPF puts you in the field and just sits you there at the beginning. So if you start typing, everything else moves at the end. That's great, but not if you've been used to 30, 20, 50 years of form processing style in Windows that does the select it all when you get focus. That behavior fixes that. So using a style, you'll get WinForms style processing. This is all to do with, the first bit of it is to do with focusing. Again, don't worry about how you get focusing to work. Just assume that you're using styles and it will work. That second data trigger there, that's all to do with the validation. And if the validation has an error, then this line gradient and gradient stops basically just gives you a red shaded background to whatever control you're on, be it a data picker, a text box, whatever. So it styles it and says, this field's in error. So you don't get a prompted, you've got to stop and answer this type approach. You just get indications on the form that something's not right. You can hover over them and see the toolkit, and you'll see, if you look at the third line down where it says value binding element name equals, that's the name that I called the style right at the very top. So I'm using the name of the style to reference it by element name inside the XAML. That's all well and valid and good. So you've got your style. There's a good, 20, 30 plus lines of code there generated from a repository structure. If you had to code that in every time you wanted to add a field to an input form, it would be a bit arduous. So it makes life a lot easier. The top line, that's your label. So you've got one line to say, that's where I want to see my label. The second line, and that's the anchor point I was talking about, the field control. And that's just so that the style can be anchored to any type of control, and you will see a text box, a date picker, combo box, etc. So the second line, the grid row column is just positioning it, because generally you'll define a grid of columns and rows of, I want prompt here, field there, prompt here, field there, prompt here, field there. And then you've got the static resource, part ID prompt for the label, part ID style for the input style. So those two lines of code is all that you'd put in your XAML. So that's how you code. That's your dot script, dot input, dot field, dot field. Okay? So that's the equivalent of your one line of dot field inside your input form. Hopefully you can see that styles can make things an awful lot easier and simpler to handle. This is inside the view model. This is where we're going to define an input set. So you're going to pass in the set name, and then you're going to code for that particular view model, for that particular program that says, well, if they want input set new, then that's all the fields. And if you go back inside your script file, you'll have .input, .field, and then you'll have .set, name new, all. You'll have .set, name modify, and then a list of fields, okay? Which would be ID and group. So basically what I'm doing here is saying, well, if the modify, set all the fields enabled to true, and then disable individual fields. And that's just showing the different ways that you can set enabled and disabled. So those three lines are doing the same thing, but different approaches to different fields. That line at the bottom, that's how you set focus to a field. So at any point in time in a Symfony-based development like this, if you say field name is focused, it will get focus. So when you bring up a new form, you can say field focus. That's one line of code. It's an awful lot more to actually make it happen, believe you me. It's a huge amount more. So think about the way input processing works. If you look at the input window we've got in our example, you've got ID at the top, and then group and supplier, etc., etc. When you say, I want to create a new one, you set all fields enabled, and you go into IInput, you initialize the data, and you go into IInput, and what happens? What happens when you go into IInput? It will take you to the first uninitialized field inside the input set. Correct? If you display into an input window, to all fields, into an input set of all, and then you go into IInput, what happens to focus? It's on the OK button, Sylvia. Thank you very much. Because the way input processing works, it says, okay, I'll go to the first field that's not had something put into it. So unless you initialize something, it'll drop off the end, i.e. go to the input button. If you don't put a button on there, and you specify no term, it'll just drop out of IInput straight away. You know? So there's a few caveats with toolkit processing, which we've been able to sort of allow you to code. I'm not saying we honor it, we allow you to code it. So what's happening here in the modify is, you're saying, set all the fields enabled, so that's my set all, then disable the ID, and then set focus to group ID. Otherwise, it wouldn't know where to put focus. The WPF isn't like Toolkit. It doesn't go, no, I'll put you on the first one that you've not done anything to, or not given any data to. It doesn't work like that. You will have to code where you want focus to go. Now, focus is a UI thing. And this is the view model. And the view model shouldn't do anything about UI, and the UI shouldn't know anything about the view model. Correct? Well, it's not a UI thing. You're setting a property called group ID is focus. What's it doing? You have no clue. What it's actually doing is raising the event to the view saying, will you put focus on this field? Will you make me available to enter the next time the whole control gets focus? It's up to the view and the designer of the view to honour that. If they've not used styles and they're not listening to the property raise group ID is focused property changed, then it won't get focus. Okay? It's only because we've done a binding in the styles between the group ID is focused and getting focus to a start using a style that field will get focus. It doesn't, all this just doesn't happen out of the box with XAML. That's why Symphony Framework's been written and all these styles have been developed to allow you to just say, don't enable those fields and put focus there. There's oodles and oodles amount of coding that's going on behind the scenes and sort of ever so nice and sweet requests to the user interface. Say, please put focus here. Okay? It's not simple, this stuff. Not like your Toolkit days. So anyway, I bored you enough with input processing. Input processing, the next exercise that I'm going to give you is relatively simple. So it's actually only that. Okay? You've only got about 10 lines of code to type in.